Hey everyone, hope you're doing well today. In this video, let's simplify down the process of verifying this trigonometric identity together. For this example, we have secant of theta plus tangent of theta is equal to 1 over secant of theta minus tangent of theta. To verify that these two expressions are equivalent, I'm going to try to make the right side look like the left side. To get started, let's remember that secant of theta is a reciprocal function, which is just 1 over cosine of theta. On top of that, it's really important to know that tangent of theta is equivalent to sine of theta divided by cosine of theta. I'm going to go ahead and use these identities to rewrite this expression. Substituting in, let's go ahead and write 1 over cosine minus sine over cosine. The reason why this is nice is because both of these fractions on the denominator have common denominators of cosine of theta. Since they have common denominators, we can rewrite the denominator as one fraction and say we have 1 over 1 minus sine of theta over cosine of theta. Now remember, we can look at fraction bars and consider them as division symbols as well, so we can rewrite this expression as 1 divided by 1 minus sine of theta over cosine of theta. Since we can rewrite division as multiplying by the reciprocal, we can rewrite this as 1 times cosine of theta over 1 minus sine of theta. And by the identity property, we can just drop that 1 and just write cosine of theta over 1 minus sine of theta. But what do we do with this now? At this point, we have a cosine and a sine, but we really need to have a secant and a tangent. To begin getting rid of this sine of theta, let's go ahead and multiply top and bottom by 1 plus sine of theta. Since 1 plus sine of theta over 1 plus sine of theta is just equal to 1, we can do this without changing the expression. And the reason why I think this might be helpful is because the denominator looks like this pattern of difference of squares from quadratics. Just a little refresher, if you multiply the quantity of a plus b times the quantity of a minus b, that's just really going to factor into a squared minus b squared. We can go ahead and use this pattern to help us with this 1 minus sine of theta times 1 plus sine of theta. Rewriting this all as one fraction, we're going to get cosine of theta multiplied by the quantity of 1 plus sine of theta, and in the denominator we're going to have the quantity of 1 minus sine of theta times the quantity of 1 plus sine of theta. Well, we're just going to go ahead and leave the numerator alone for now. Let's go ahead and multiply out the denominator, or FOIL it. Distributing out the denominator, or FOILing, we're going to get 1 minus sine squared of theta. And just in case you want to see that work written out a little bit more clearly, here's what that looks like. Looking at this 1 minus sine squared of theta in the denominator, that looks a little bit interesting to me. This is where you're going to want to remember one of your Pythagorean identities of sine squared of theta plus cosine squared of theta is equal to 1. If you rearrange this identity a little bit, we can also say that 1 minus sine squared of theta is equal to cosine squared of theta. And so that's super exciting because I think we can use that to help us here. So in the numerator, we're still going to have this cosine of theta times the quantity of 1 plus sine of theta. And for the denominator, we're going to swap out that 1 minus sine squared of theta for cosine squared of theta. Next, we're going to go ahead and simplify down this fraction by dividing top and bottom by their GCF of cosine of theta. And when we do that, we're going to be left with 1 plus sine of theta on top and just cosine of theta on bottom. Now remember, if we have a sum on top of a denominator, we can go ahead and separate that into two separate fractions if we would like to. So splitting this up into two separate fractions, we can rewrite this as 1 over cosine of theta plus sine of theta over cosine of theta. And if you need to pause the video anytime just to think a little bit, feel free to do so. Now let's think about why we just separated the fraction. The reason why this is helpful is because this 1 over cosine of theta looks really familiar from the beginning. Reusing one of those identities from earlier in the video, we can rewrite 1 over cosine of theta as secant of theta. And this sine of theta over cosine of theta should look familiar as well. Similarly, we can use the other identity that we used at the beginning as well. Substituting in, we can rewrite this as tangent of theta. And there you have it, the right side of this equation is now secant of theta plus tangent of theta, which matches the left side that we had at the very beginning. Now, if you found this video helpful in understanding trig identities a little bit better and you want to share it with some of your friends or classmates, feel free to do so and help them out as well. As always, I want you to keep up the great work that you're already doing, and remember, don't forget to simplify.